Hello guys, today we will discuss significant digit. Here the number 2.63 has 3 significant digit and the number 0.0263 also has same significant digit, but 0.2630 has 4 significant digits. Why? What is the reason? Let's try to understand with the set of rule that governs in finding the significant digits of a number. And first of all, let me tell you what is significant digit. Okay, whenever we do some experiment, we report the result with a combination of certain digits that we are sure and a digit we are not sure. Okay, and here is the typical result of a measurement of the radius of a circle, which we are representing means giving as r is equal to 2.63 centimeter, and the number here is 2.63 r certain, means we know exactly their precision, while the number 3 has some uncertainty in it, and this is, and the number 2 and 6 3 are reliable and the quantity 3 is unreliable. Okay, so representing a number with a combination of reliable and the unreliable digits is called significant digit, and the radius of the circle here has 3 significant digits in it. And changing a unit system will not change the significant digit. The same radius I am representing now in meter, and this can be represented as 0.0263, and same can be represented in millimeter as 26.3. In both cases it has the significant digits of 3. It won't change. Okay, so there are some rules to find the significant digits of a number, and the first rule is all the non-zero digits of a number are significant. Means here you can see there is no zero in this number and it has 3 significant digits, and all the zeros between non-zero numbers are significant. This zero is stuffed between three non-zero numbers, and hence it became a significant digit, and same is the case here, it has 4 significant digits. Okay, now the preceding zeros after decimal and before non-zero digits are insignificant. Whenever a number is less than 1, we used to represent it by a 0 before decimal, and hence this also become insignificant, and zeros between decimal and non-zero numbers also insignificant. These two zeros here are insignificant, and this number has 3 significant figures only. Okay, now we can represent a quantity in different unit, and 263 meter can be represented as 26300 centimeter and 26300 millimeter. In all this case, it has 3 significant digits. Okay, that means in a non-decimal number all the trailing zeros are insignificant. That is what it means. These are insignificant. Okay, uh, now after decimal means all the trailing zeros after decimal are significant. Here you can see it has 4 significant digits, and it also has 4 significant digits. Okay, this 0 is insignificant, as I told here. It is all the preceding zeros before non-zero number and decimal point are insignificant, hence both are has same 4 significant digit, and all the trailing zeros in a non-decimal number are insignificant, and it has the significant 3 significant number, and once if you put a decimal point, then these zeros become significant, so this has a 5 significant digit. Got it? Okay, now so there can be a confusion that so we are representing the radius by 2.63 meter. Okay, so this 3 decimal point represent the accuracy of an instrument that we use to measure the radius of the circle. Okay, now this can be represented in centimeter as 263.0 centimeter and 263.0 millimeter. Here you can see the number of significant digits are 4. Here also 4, whereas here it is 3 only. So changing units changes the significant digit, but that should not be the case. Okay, to avoid this confusion, we can use scientific notation. Okay, this quantity can be represented as 2.63 into 10 raised to 0 in meter, and this can be represented as 2.63 into 10 raised to 2 centimeter without changing the base numbers. Here bases are same, whereas the order of magnitude only varies when we change the units. Here in meter it is 10 raised to 0, in centimeter 10 raised to 2, and in millimeter it is 10 raised to 3. That's all.